everybody, I hope that you're doing well. So last lesson, we dove deeply into learning a whole lot of exponent rules, and we also kind of introduced scientific notation. Now, that was a whole lot in a pretty long lesson, but that lesson's a little bit longer so that this lesson can be a little bit shorter. Last lesson, we introduced everything you need. This lesson, we're just going to put it all together. Okay, so that's why the title is More Exponents and More Scientific Notation. So the idea here is we're going to work on simplifying things using our exponent rules. And we would like to smush all the like bases down to a single base as much as possible. Now, if they're different bases, obviously they cannot be combined or cannot be pushed together into a single base. And the other cool thing about this is order does not really matter. There are many different ways to do these. Okay, so I'm going to just jump in with a few examples, and let's see how we feel about this. So let's go 5 to the negative third power over 5 to the negative fifth power. And there are many ways to do this one. But first, I just want you to notice that 5 and 5 are the same base, so I can try to combine these into a single base. There are so many ways to do this. One would be, you could say, hey, I don't want to deal with negative exponents, so let's fix both of these bases and their exponents. So you'd move one up, move one down, then do your division rule. Another way would be to move this one up and just combine the like bases with your multiplication rule. I'm actually going to, because I've done so many of these, I can see and kind of do some in my head and check which one will be faster. I am actually going to dive right into the division rule for like bases, which says you take the top exponent, which is negative 3, and you subtract the bottom exponent, which is negative 5. Okay? Now, what is negative 3 minus negative 5? Some scratch work here. If you typed that in your calculator, it would tell you it's positive 2. Why is it positive 2? Well, that's because, remember, this minus a negative, these two negatives side by side here, make it plus a positive. So it's just negative 3 plus 5, which is positive 2. So this is 5 to the positive 2. And I'm okay. The test will try to give you explicit directions. Maybe I should say I'm not okay. If it's a 2 or a 3 with a simple number, I would like for you to go ahead and figure out the number, 5 squared. 5 squared is 25. If it's a 4, 5, or 6 or a higher exponent, you're fine to just leave it as is. Okay? So there, we've simplified this from this nasty fraction with exponents down to just 25. That's nice, right? So let's keep on moseying with working with these exponent rules. So another simple one like this. 4x in parentheses, all raised to the negative 2 power. And so remember, we have a rule for, now these are not the same bases, so I can't do anything to combine the 4 and the x more than it already is. And so we have an exponent on the outside of our parentheses here. And so remember, the rule is it gets multiplied by all the exponents that are inside. Well, you don't see any exponents here, so you can put 1s on both bases. And so the exponent rule is just to multiply both of these exponents times negative 2, which would give you 4 to the negative 2 and x to the negative 2. Now, I cannot leave this with negative exponents because that would be improper. So if I make this a fraction, I see that the 4 to the negative 2 is on top of the fraction, so I'm going to need to move it down to make that a positive 2. 4 to the 2. So remember, if you take a base and its exponent and move it up or down in the fraction, it just changes the sign on the exponent. And I have to do the same thing with the x to the negative 2. I'm going to take it and move it down. X to the negative 2 becomes x to the positive 2. Okay, now there's nothing left up top, so I need to put a 1. And so there we go. I can do 4 squared. I just told you if it's a simple number with a simple square. So 4 squared would be 16. Alright, so I got 1 over 16 x squared. Okay, so we're just using all these exponent rules and practicing a little more today. We're going to combine more things together. So look at one like this. 28x y to the negative 5 divided by 7, x to the negative 3, y to the 5. Okay? I'm going to just start by first noticing I have numbers 28 and 7. Does everybody see that? 28 and 7. And you can kind of just handle the numbers, the x's and the y's all separately. 28 divided by 7, that is just 4. 4 over 1. It reduces. Okay, and now let's use our exponent rules on like bases. So notice I have x and x. There's no exponent shown here, so I can just put it as a 1. Now I can use the exponent rule, which tells me to put, if I'm dividing like bases, I put the x on the top, and I take the top exponent minus the bottom exponent, which happens to be negative 3. And I will do the same thing with the y's, like base, top exponent, negative 5, minus the bottom exponent, which is 5. So let's see what we get when we do that. I have a 4 up top. I have an x to the, 1 minus negative 3, that is x to the 4th, and y to the negative 5 minus 5, that is y to the negative 10th. Okay, and that's all on top of the fraction, right? I can't leave my final answer like that because I have the negative exponent right here. So this y in negative 10th, this y to the 10th, is going to have to move to the bottom of the fraction to make that a positive 10th. Because that's one of the rules we covered last time. So I'm assuming that you have watched the last lesson. Oops. And I'm assuming that you know all of our exponent rules now. We're combining them all, using them all in each problem. So there, that is nice and simplified. There's only one x base, there's only one y base. They're all positive exponents. I should feel good. We can do more things like that, where we combine big expressions like negative 3, x to the 3rd, y to the 5th, close parentheses, new parentheses, 2, x to the 4th, y to the 2nd power. So this is just two big groups, two big terms being multiplied, right? And so when I go to multiply these, why don't we can rearrange multiplications all we want to. Do y'all remember when we covered those annoying topics? But I told you that multiplication was commutative and associative, which means I can jumble up these multiplications all I want. I'm going to rearrange these and put the numbers beside each other, the x's beside each other, and the y's beside each other. Because these are just all multiplications in between all of these bases and exponents, right? So now you look at what I have, and I can handle this in chunks. I can multiply plain numbers. I could combine these like bases, and I could combine these like bases. So let's see. First chunk, what is negative 3 times 2? That is just negative 6. Piece of cake. Now x times x, what is the exponent rule for handling the exponents? I can combine it into a single base, and I've got to add the exponents. And the same thing with the y's. I can combine these into a single base, but I've got to add the exponents. So let's see what we get. We get negative 6 times x to the 3 plus 4, that is 7, times y to the 5 plus 2, that is also 7. Okay. All the exponents are positive. I don't care that the number out front is negative. That makes no difference. So it looks good. We've simplified that one. Okay. Maybe two more examples just to get a good feel for these. One like this. Let's do a 2x to the negative 2 over y to the 3rd. And let's put everything in parentheses, and on the outside, let's give it a negative 2. Okay. So once again, this parentheses rule tells me all the exponents on the inside are going to get multiplied by negative 2. I don't have an exponent on this 2, so I can give it 1. And so what does this end up looking like? 2 to the 1 times negative 2, x to the negative 2 times negative 2, over y to the 3 times negative 2. And let's finish this step. Let's see, 2 to the 1 times negative 2 is negative 2. X to the negative 2 times negative 2, that is positive 4. And in the denominator, y to the 3 times negative 2, that is y to the negative 6. Okay? Now, this looks almost finished, but I have a term right here, which has a negative exponent. You see right here. And I also have a term right here that has a negative exponent. So both of those are going to have to move. So 2 to the second power is going to have to move to the bottom. The x to the fourth gets to stay put, right? So when I move 2 to the negative 2 to the bottom, it becomes 2 to the positive 2, because that's the rule. I can move something from top bottom or bottom to top, and it changes the sign on the exponent. And I'm going to want to do the same thing with y to the sixth. Y to the sixth will move up top and become a positive 6. So notice there's a few steps there. There's several different orders you can work this in, but you do need to try to make sure you get the correct answer. We can handle 2 squared, can't we? I just noticed how simple that was. 2 squared is 4. There. Alright, awesome. Maybe one more, and then we'll move on to something else. 4x squared, and let's put that in parentheses, and times another set of parentheses. Let's go with x to the negative 5 divided by x to the third. And you can, it doesn't matter if that has parentheses or not. Alright, so we look at this, and I just have a 4 there. The 4 doesn't have any other numbers to mess with it, so I know I'm going to have a 4 on top of the fraction. But you look here, and I have 3 like bases to combine, and I can combine these in any order I want. I could move the 5 down. I could combine these two first by multiplication. That's probably what I will do. So up top, I'm going to leave the x to the third on the bottom for a second. And up top, I have x squared times x to the negative 5th. And the rule tells you if you are multiplying like bases, you add their exponents. That's hard to see. Let me write it a little bit neater. So 2 plus negative 5. So what is that going to give me? It'll be x to the negative 3 over x to the third. So there are 2 different ways you could go here. You could go ahead and combine these bases, or you could go ahead and move this negative exponent down and then combine them. I'm going to go ahead and combine them. It does not matter what order you do these steps in. You will get the same answer if you're careful with these. So the rule for combining these says if they have the same base, we move them up top, take the top exponent, which is negative 3, and subtract the bottom exponent, so minus 3. What will that give us? That will give us 4x to the negative 6. Now I cannot leave my final answer like that. This is understood to be the top of the fraction, so x to the 6th will have to move to the bottom to become a positive exponent. 4 does not have a negative exponent, it stays put. Okay? So that's a lot of practice on just combining all these exponent rules. Make sure you do practice the worksheets. Those are more good practice on doing these. I'll post all the answer keys for them at some point. And hopefully that'll just help cement some of those ideas. Okay, so now we have one more idea. So we taught scientific notation last time. And it's kind of weird to try to combine that with exponent rules and also to understand the usefulness, but I'll show you the usefulness in scientific notation. If I would like to do operations with big numbers, so this is what I mean, like 2,000 times 900,000 divided by 0.0003 times 0.01, I would not want to do that without a calculator. But with scientific notation, we actually could handle this without a calculator. Here's what we will ask you to do. We will ask you to convert all 4 of these numbers to scientific notation. And so we covered how to do that last class. So 2,000 would be 2 times 10 to the 3, because we moved the decimal place 3 times, 1, 2, 3, and it's a big number, so it gets a positive exponent, times 9 times 10 to the 1, 2, 3, 4, 5 to the 5. Okay, because we moved the decimal 5 places, and 900,000 is a large number, so it gets a positive exponent. On the bottom, we're going to do the same thing. So this will be 3 times 10 to the, let's see, 1, 2, 3, 4. Make sure you move it behind the 3. So that's a negative 4. Why is it negative? Because this number represents a tiny decimal. Okay, times 1 times 10 to the negative 2. Because I got to move this decimal twice to get it behind one digit. Okay, now notice I wrote it a funny way, but notice something about this. These operation symbols, oops, did not mean to erase all that. These operation symbols here are just multiplications. Couldn't I just use dots for those? You see that? So I could just use dots for these multiplication symbols. There's a reason I'm wanting to use dots, because I have dots in between them. These are just 4 things up top being multiplied and 4 things on the bottom being multiplied, and the order of multiplication does not matter. So I could rewrite this as 2 times 9 times 10 to the 3rd times 10 to the 5th. And on the bottom, I could rewrite it as 3 times 1 times 10 to the negative 4th times 10 to the negative 2. So this, you may not see why I'm doing this yet, but you're like, okay, I do see that you can rearrange multiplications, and all I have on the top are multiplications. All I have on the bottom are multiplications. Let me show you why I'm doing that. Because I do know 2 times 9. 2 times 9 is 18. And wait, 10 and 10 are the same base. I could just use an exponent rule to combine these two 10s. 3 plus 5 would give me 10 to the 8. So I have 18 10 times 10 to the 8th. That's scientific notation right there. I've converged or smushed these two scientific notations into a single scientific notation. And I can do the same thing here. 3 times 1 is 3 times 10 to the, and so 10 and 10 have the same base. I would just add their exponents. Negative 4 plus negative 2 is negative 6. And so I have simplified these 4 separate big numbers, or big and small numbers, into 2 scientific notations. And I'm not finished yet. I can keep going with this. Move this over to get me some more space. I can keep going with this because this is a division, and I know how to do divisions as well. 18 divided by 3 is just 6 times 10 to the, and I can use my exponent rule. Remember, my exponent rule for division is to subtract. So 8 minus negative 6. And so what will that be? Let me rewrite it here. 6 times 10 to the 8 minus negative 6 is 14. So I got 6 times 10 to the 14. That's kind of a large number. If you were to expand that back out, let's see. Well, I don't know where if the decimal will go right there. Hang on, or the comma will go right there. Let me erase that. So this would be 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. This is a rather large number. I'm just showing you how big the number ends up. We would not want to do this in our head. With a calculator, this would actually be difficult too, because the calculator will not carry this many decimal places, so it will give you some jumble of stuff. So let's not do that. Let's just say the answer is 6 times 10 to the 14. Okay, and so that is a question you'll get asked on the test. They'll ask you some simple questions of, hey, can you write this in scientific notation? Hey, can you take this scientific notation and write the number, expand it to the normal number? And they will also ask you one where you're multiplying and dividing big and small numbers. And the best way to do this is to use scientific notation to get your final answer. Okay? So, that is section 1.6 and 1.7 all tied up. We learned exponent rules, So I do need you to be able to do things like this for the test, where you just use your exponent rules to simplify things down. We learn scientific notation. Okay. Now next lesson, I think will be on Friday. Next lesson, we'll be able to finally get down to chapter 5 business. Okay. And it's we will use some of this stuff in more of section 5.3. We're going to start with 5.1, and so we kind of take a time out from this. So don't lose this stuff from your memory, but we do move on, okay? Well, that's all I have for you today. Have a wonderful day, guys.